Hey everyone, welcome to another video on Blender Geometry Nodes. In this video, we will see about curve read nodes. This is the third part of the curve read nodes tutorial. There are few set of nodes which we need to cover separately, hence the separate parts. I release new videos on a weekly basis. Please subscribe to my channel so that you will be notified when I upload a new video. This is Jay from CJ Academy. Let's start. Okay, I have my custom workspace setup. I'll share the link in the description how to set it up. You can take a look. We don't need the cube. Let's keep this aside. We are going to see about the curve read nodes, and in this video we will see about three nodes in specific: curve tangent node, okay, curve read, curve tilt node, and read node endpoint selection. Okay, so curve tangent, so you already see this is already in purple color. That means it is a vector output. Okay, to really see this, in our case we are going to see about curve, so we need some kind of curve geometry. The primitives we already covered all of it. I'll pick the spiral node, and for curve tangent let's take Bezier node. It only have very few points, so spiral will keep it aside. So Bezier node and curve tangent. Curve tangent is nothing but for each control point, whatever the point it is and how the curve propagates from there, the curve's tangential position is what this data will have. Okay, to see this we need a viewer node, and let's connect this. Okay, you have the viewer node here, and if you see the spreadsheet editor, come to the curve section, you see the viewer node has some data. I told you this is a vector value, but what you see here is a float value. This has to be changed to see the exact values, and for that you have to come to the hidden menu by clicking this and select the node. In our case it's the viewer node. Go to the node section so that you can change the property of it from float to vector. Now you see the full XYZ value coming up here, because this is the tangential information of this point, okay, of this control point, and one is the tangential value of this control point. Okay, so to see how this point propagates, or this line, the tangential look like, you can imitate this by using a joint geometry, okay, and imitate this particular value with a curve line. Okay, so observe the curve line has a start and end point. End point you leave it, it doesn't matter because we don't have endpoint value here. It's only the line, particular points tangential value. Okay, so let's keep this to 0. So the x and y has the same value, so you can select both and type 707. Okay, and third one is 0, that is correct. Now if you connect this to here, so if you see it goes in this line, it's this direction. So if I put a transform geometry node here to bring it to this point, that's exactly here. That means here we have to put -2, oh sorry, -1, because the origin was 0. So you can see now, so the tangential direction of this point is up this way. Okay, similarly for this point, it is actually only in x-axis it has a value, remaining 2 are 0. So if you just put starting value all 0 and only x is 1, that means, see, it will have a tangential for this point. Now if you change this endpoint to a different value, then this tangential information will change. Okay, I will disconnect this connection just to keep this value as it is. Now if I change the endpoint in z-axis to some value, so you can already see this is changed because this point is changed. And let's put some, sorry, here, yeah, like that. So now we'll imitate the same value. So this is curve line, start values 0.639, next value is 0.511 and 0.575. Okay, and now let's this we don't need it now anymore, and let's unlink this. So you can see this is going a tangential to this point. So the curve tangent gives you that value. So what we are doing here is we are taking the geometry's tangential value. Of course, there is a line, that's why you have 2 and 3. And if I just mute this, you don't have it. So this right now giving you the Bezier curves to control points tangential value in vector float value. Okay, so that's what curve tangent does. So you can utilize this value to any operations you want, and this may be a crucial information because curve means it's always about the tangential. So curve will be smooth only if it is tangent. So having the data as a node is very helpful. So that is about curve tangent. Now let's see about curve tilt node. Okay, curve tilt node gives you a tilt value output in degrees, I mean radians. Okay, for this you to set this value you need set curve tilt node. So okay, separately this doesn't have any value. It is not assigned. It is not having any data to it. To write a data to this, you need this node. Let's say you don't want this. You just want to connect it here. Okay, and now this is radiant value and this is a vector value. It's not exactly same. I'll change it to float, which is the default. I'll leave it as it is. But if you see, this is still 0 because the curve tilt node has no data yet written. There's no tilt property created or written. So for that reason, we'll bring this here. Okay, not here. We'll delete this. We don't need this joint geometry rules. We don't need. So let's say curve tilt node, and you see tilt value or the tilt property. This is an attribute actually. The tilt attribute is popping up in the spreadsheet editor. And as you can notice this, if I change the degrees here, you already see the values are changing here. Because I am setting up the curves tilt value to some other value, and because of that this is changing. But we will see about the set curve tilt node in a separate video. Here I used this just to show you the tilt property is not written. If you're trying to understand curve tilt node similar to curve tangent and connect it to viewer node, you won't see the data because the data is not there. You have to set it using the set curve tilt node. Only then the property appears. So that is about curve tilt node. The last node we will see today is the endpoint selection. Okay, this is a output is Boolean value. So this is a position is a vector value. Okay, curve tangent value, and this is radiant in degrees. Okay, and this is in Boolean value, whether the selection is yes or no, or true or false. Let's bring in the spiral node which we brought before. Okay, and so this is a Boolean value. Okay, so let's put this in place, and for the instancing let's bring in the cone. Okay, and connect this to the viewer node and change the cone size. It's too much. Okay, you can see. Let's increase the twist bit and height a bit. Okay, so endpoint selection is a node used for selection property. Okay, and it will count how many points you want to select from the starting point or the starting tip, and also how many points you want to select from the end tip. So if you want to understand this, I'll show you. So now start size, end size is 1, so that the last point and the first point is selected. It is not counting the index value or ID value, it just counts the number of points. So it doesn't matter start or end, it will just try to count the point. So I say 20 points, or let's say 3 points. Then from the end, so this end, it actually starts from here and goes up like this. So at the end, 3 points select. In the beginning, just select 1 point. Okay, let's say I want to put 10 at the end. So it selects the 10 points and 3 points. And if I say like this, so from the start, take 98 points, only take 3 points because it takes the point source. So whatever points it can consider, it will consider. So yeah, so this is about the endpoint selection. So I hope you got it. And if you actually control it together, you get a nice connecting. You get the point, right? So this also can be animated because it is something you can animate. So yeah, so that's about the three nodes which I wanted to cover today. If you find this video useful, please like it, share it with your friends. If you want me to cover any specific topic in Blender geometry nodes, or if you have any questions about this topic or any other topic, please let me know in the comment section. Please subscribe to my channel. I will see you in another cool video. Thank you. Bye.